Hello everyone, welcome back to the class of C programming. This time we are moving to chapter 6, pointers, and also we'll talk about how we use the pointer to pass values for functions, the so-called call by reference and pass by reference, pass by values. Okay, so let's get to the point. What is a pointer? A pointer, it is a variable in the C language. Okay, but anyway, it is for a special purpose. A variable, it is a piece of memory, and in that piece of memory, you could save any kind of data. And so far, we covered in class, there are three basic types: the int type, the char type, and the double type. Three basic types. And now I'm saying when you declare a pointer variable, you could use that piece of memory to save an address of memory, okay, inside the computer. And it has memory, and it has a lot of memory indeed. And nowadays we are talking about basically based on gigabytes, lot of them, a lot of them. And each memory cell has an address. So a pointer or a pointer variable, it is a piece of memory to save an address. I know it's harder to follow, it's harder to understand for now, but anyway, let's pretend we got it. A pointer, it is a variable to save the address for a piece of memory. So how do we declare a pointer? And like we did before, let's start from simple examples. I suppose this should be very familiar to us, right? Int m. And basically, this is the way how we declare an integer variable m. And also in this declaration, at the same time, this is m, it is assigned with the value 25. M, it is declared as the integer type of variable. At the same time, it is assigned with value of 25. Okay, let's move to the next line. Next line, especially I want to be very sensitive. It's not a typo here. The asterisk. Asterisk, basically when you are ready to declare a pointer, you are going to have an asterisk in front of the identifier you create. M, it is an user-defined identifier. itemp, it is a user-defined identifier, and you're going to follow the C language syntax to create an identifier. In general, the identifier can be the mixture of letters, digits, and underscore mark, and also could be positive, uppercase or lowercase. Okay, C language, it is case sensitive, lowercase, uppercase, or in any part you have lowercase and then with uppercase and replaced with uppercase, that would be different. C language is just designed as case sensitive. And also, as for the identifier, you cannot have an identifier starting with a digit. A letter or underscore mark is fine. Letters, underscore mark are fine, okay? And then not digits. And also, you cannot create an identifier which is already taken. And an identifier already taken, it could be reserved keyword like int for the int type. Double for the double type. You cannot take those C language reserved keyword. And also you cannot create an identifier in some common used library functions. Okay, so itemp, it is a legitimate C language identifier. You can create the identifier mostly in the way you want, as long as you follow the rules. And also because of the asterisk in the front, now indeed what we declare here is itemp is a pointer to an integer. So I really should write down in the comment a little more. Itemp, according to this declaration, we are having itemp as a pointer to an integer. And to which integer? Well, we don't know. You cannot take it for granted. Itemp is pointing to m. Okay, we'll see. We could make itemp point to m in a moment. But anyway, you really will have to say those two declarations, these are really totally different. Besides itemp and m, they are not related. Okay. And so this fashion of way it is to declare a pointer. And indeed, we mentioned that so far we have 3 data types: int type, double type, and the char type. Indeed, we could define pointers for each type accordingly. And the first example, it is, well, to the right column. Okay, to the right column, these are the pointer declarations. Itemp, like the previous one we just did, you could use a different notation. Okay, itemp, it is a pointer to an integer type. And still, I'm putting int m together because I really want you to know the difference to declare an actual variable and the way to declare a pointer. And certainly at this moment, the left column, the content in the left column and the content in the right column, they are not related. It's really, they are not related. Okay, and especially for the right column, I declared some pointers. Itemp, it is a pointer to an integer. PD, it is a pointer to a double type. PCH, it is a pointer to a char type. Okay. And then, as I'm trying to emphasize, these pointers are not necessarily related to those actual variables. But anyway, we can make them related. So when you create a pointer, we know that's an address. What kind of address it is in that memory cell, or what that pointer is pointed to, it is unknown. It is unknown. So if you want to make the point the pointer pointing to a specific value. Certainly, another thing I should have mentioned earlier. Okay, pointers, they are addresses and pointing to different memory type of variables. I'm saying the type are important. And when you declare an integer pointer to an integer type, you only can make the connection of the pointer to an integer. When you make a declaration, a pointer to a double type, you only can relate this point to a double type value. And similarly, if it is a pointer for a char, and then it must point to an actual character. Okay. Type, C language is case sensitive and the type sensitive. Okay, so far at least I want you to know 3 types: int, double, and the char. Int, double, and the char. And accordingly, there are 3 different types of pointers. These are the pointers. And then how do we make the connection between the pointers and the actual values? Let's move a little bit. Okay, this part of we know this is the assignment operator, right? And then you may wonder, what is the ampersand? I hope you remember this is really not the first time we see the ampersand. In the way when you take the import using the standard library function, import and output function, scanf, we said the variable will have to be preceded by the ampersand notation. Now, I really want to tell you, well, m, certainly it is the name of the variable. Indeed, it occupies a piece of memory. And that piece of memory has an address. So when you are in the ampersand notation, ampersand really it is an operator. It is C language operator. It is taking out the address of this variable m. Address is the pointer, right? Now I hope it makes sense. We can assign the address to a pointer. We can assign the address to a pointer. Assign the address to a pointer. And indeed, I'm just going to say, itemp itself, it is a pointer. It is a pointer. It is pointing to the variable m because it just is assigned. It is assigned with the address of m. It is assigned with the address of M. And then, well, many times you may wonder, we really don't need to know the address. Even many times for programmers, we really don't care which address you have. We just needed to know the content. And certainly you will see in a moment. Okay, in other examples, we do need to know the address because in many ways, to write a computer program, to write a C program, basically you're going to manage memories, and you're going to manage memories very well. Not only knowing the content to manage memories well, you do need to know the address of memories. So itemp, now at this moment, it has the address. Okay, let's put it aside. We got it. Itemp, it is an address, and we'll see how we use the address later on. And then how do we know? If we know the address, how do we know what's the content in that address? And indeed, it's a very simple thing. Okay, ampersand, it is taking out the address of a variable, and then you want to put an asterisk in the front of the point variable. It will take out the content of the variable. So I said in the comment part, asterisk itemp, it is equivalent to M. Or really, the content-wise, they are the same. So whenever you want to use the content from address, you apply the asterisk operate before the pointer. By the way, it's worth to mention, so far, I think we see different meanings of asterisk, right? At least we remember asterisk, it could be it is the operator for multiplication. Now we can say the asterisk, it's not necessarily multiplication when it is applied right before a pointer variable. It is taking out the content of the pointer. Asterisk of a pointer variable, it is for the content of the pointer. So similarly, when you have point to a double type, certainly you can take out the address of the double type assigned to the pointer. Take out the address of the char and assign to the pointer for the char type. And similarly, the ampersand, it is taking out the address of variable. Asterisk applied to a pointer, it is taking out the content. So put in a simple way, I'm saying asterisk PD, it is really equivalent to D. Asterisk PCH, it is equivalent to a character, CH here. Okay. And then let's just talk very quickly, well, a technical term. And usually we talk about a variable, we think about its value. And that's basically, it is called as direct reference. The name of the variable, it is directly used to reference, to relate to the value. And when you have a pointer, okay, preceded with an asterisk, it is so-called indirect reference to the value. Okay, because you have a point first, and then you take out the content using the asterisk notation. That is the indirect reference. Okay, and whenever you have a pointer and then you want to take out the content of the pointer, it is always considered the indirect reference. And this is the chart. Basically, I just took from the textbook directly. I'm not sure. It might be confusing, even though I talked a lot. Pointer, address, and the content, and the variable. How do we understand the situation? So, M, I suppose it's easy to understand. It is integer type. Indeed, we do have an integer variable assigned here. Okay, integer value assigned here. Itemp, it is also a piece of memory, surprisingly. Really, somewhat they are equivalent. They are equivalent. That is a piece of memory. This is also the piece of memory, the gray area, believe it or not. And then it may have a value 1024. I hope you will see, we will see this 1024 a lot. And it is 10 to the power 10. I think we also mentioned it before. 10 to the power 10 in computer science, many times we use the multiple twos. 2 to the power 10, that's 1024. And the counting bytes, 1024 bytes, it is 1 kilobytes, 1 kilobytes, okay. And also, in this case, 1024, it is considered the address of this piece of memory, this kind of purple colored memory here. Okay, this piece of memory has an address. The address, let's say, it is 1024, and the textbook did very well because this 1024, it is printed in the same color. And also, there's an arrow here. Okay, 1024, it is pointing to that address. And then how do we access the value? Access the value of this 25 in that address. You use the asterisk notation, asterisk itemp. That would represent the value or the content of the memory cell. And still, there's another table from the textbook. You may want to take a look if everything makes sense to you. It might be hard. It will take a while. And I would say, well, it is expected you do read the book and do give a try. And also, just don't spend too much time thinking about pointers and the variables. And certainly, if you have a clear picture, you do understand everything clearly, that's perfect. If not, hopefully, when we move to actual examples, you will better understand the difference between pointers and the variables. So before we move forward, let's take a break first. Thank you for watching.